Hi guys, Mr. Bennett here. Today we're just going to look at the projectile path and the effects of air resistance on a projectile. So obviously the parabolic path, if we're looking at a situation where we're going from ground to ground, what this diagram is showing you is that the horizontal velocity, the red vector, stays the same direction the whole time, same length, same it's not going to change. The fact is, we know that the horizontal acceleration is 0, so the horizontal velocity needs to remain constant. We know that the blue vector gravity is always going to be acting downwards at 9.8 meters per second squared. So that's that particular part. The thing that will change due to gravity is the vertical component of velocity. So obviously here, that vector there it's bigger than that vector there. At the top of the flight, we know the vertical velocity is 0 there, and obviously when it gets past the maximum point, it then has a negative velocity, and that will increase. Now, if this is a ground to ground, we can assume that this is going to be symmetric. So if that's going up over here at 2 meters per second, corresponding height over here would be going down at 2 meters per second. Leaves the ground at 30 meters per second, it will hit the ground at 30 meters per second. Got the idea? Obviously, in the case where it's a ground to ground, we know that the time to get to its maximum height will be half of the time of flight. Alright, so if we say it takes 4 seconds to get from there to there, then that particular point up here will correspond to 2 seconds. So the maximum velocity you're going to have is obviously when it's been launched at the ground. The minimum velocity it's going to have is when it's at the top. The reason that being is because the velocity vertical is going to be minimum at that point. The horizontal velocity stays the same, no matter wherever it's starting or where it's finishing. So obviously the addition of those two vectors means that the minimum velocity is going to be at the top, the maximum velocity is going to be at the bottom, alright, due to that particular case. Obviously, when we start talking about being at a particular height, launching from a particular height, what we need to assume is that this is exactly the same. It's over here. So this will be exactly the same if we're launching from a particular height. We would need to think about drawing the line there. So that's why it basically still follows that projectile path, but all we're doing is we're starting from a higher position. Alright, so keep that in mind. We'll talk about that in class. So obviously to find your final vector, it's a vector addition of the horizontal and the vertical velocity, and so therefore you need to use Pythagoras to find that. Now, the overall effects of air resistance are the following. So air resistance opposes the motion of an object. So if you're thinking about horizontally, it's going to oppose it moving horizontally. So what that will do, it will reduce the horizontal velocity. It will reduce, obviously, the horizontal range. Alright, so that will be the effects of air resistance. Obviously, when we start talking about vertical velocity, then we need to consider it's going to oppose the motion on the way up, but it's also going to oppose the motion on the way down. So that will in fact decrease the vertical velocity on the way up, meaning it won't go quite as high, and therefore the time on the way up won't be quite as long. But on the way down, it will actually also decrease the velocity, which will actually increase the time of flight on the way down. So what happens here is the overall effect of the time of flight is in fact negligible. Alright, so if it's got air resistance, it probably will have roughly the same time of flight. Now, obviously in an extreme case where you have something like a beach ball, that would be probably a little bit different, alright, for that scenario. So if we started talking about the case of a cricket ball versus a normal projectile versus a beach ball, alright, because a cricket ball has a fairly small surface area and it's quite massive, it's not affected as much by air resistance as, say, something like this might be a shot put or something like that. A beach ball, though, because it's very light, got a massive surface area, it's going to not follow that parabolic path, but it's going to have a that sort of path there where it doesn't go near as high and certainly doesn't travel as far in its range. Alright, so you get the idea in terms of that. This is critical that you actually understand this concept here. Alright, so in terms of the words, how you use it, how you explain it will be up to you, but the critical concept here is about the air resistant opposing motion, and you need to better talk about these factors: what's happening to the vertical velocity, the vertical displacement, and the time of flight. Okay, in these situations. So good luck with that. Make sure you understand that, and if you need to get some extra help, please make sure you ask.